So I mentioned at the end of the last video that this is the point where we're going to start giving our character a reason to go pick up the batteries, to make this more like a game. The rules of the game are generally set in the GameMode class. Over the next few videos, we're going to set up some rules and then change how other classes behave based on those rules. Our template that we started with actually already came with a GameMode, so let's go ahead and save our level. So save all, just to make sure that any placing this spawn volume in the world gets saved. And we'll close out of the editor and start editing that GameMode class. So again, in the solution, if you go to tutorial code source, tutorial code module, you should see our tutorial code GameMode header file and the source file. So let's go ahead and open both of those up and then go to the header file. So again, in this game mode, we're going to override the tick function because on each tick, the character is going to lose a little bit of power. So just like the tick functions we've overridden before, it's the same syntax here. And we'll also set up a variable to change the rate at which our character does lose power. So we'll call this float decay rate. And we'll make this obviously a uProperty so we can manipulate it and so the engine knows about it. And let's make this edit defaults only, blueprint read write. And we'll put this in our category of power, which we've set up on a couple of other classes previously. So if you notice that this is blueprint read write, so we can tweak variables like this in code, but in a lot of cases it's faster to just set up a default value here and then make small adjustments in a blueprint based on this custom game mode. So we've already started with our modifications to the game mode, and now let's go set a default value for our decay rate over here in the class constructor. So we'll just say that our base decay rate is 1. And again, we can manipulate this either within the code, or if we wanted to, we could make a custom blueprint based on this game mode and manipulate it directly within the editor there. Now, we did override the tick function, so we'll set up the tick function now to decrease the character's power in each turn. So our game mode, we need to include tutorial code character.h because we're going to be directly accessing our character here. And our game mode ticks by default though, so we don't need to add anything about that B can ever tick Boolean. That's already set up. This game mode will already tick for us. So let's start with defining our tick function. Seconds. So first we're going to access our character. We do this with the gameplay statics get player pawn helper function. So we also need to go back up to the top of our source file and include the Kismet gameplay statics. So these are actually functions that you might recognize more from working with blueprints, such as get player pawn, but they can also be used here as long as you include that gameplay statics library. So if you notice, we created a variable of type our tutorial code character, and so we actually need to not only get the player pawn, actually let me just zoom in here, we not only get the player pawn, but we cast it to our specific character. That's so that we can access that power level that we set up previously. So if my character's power level is greater than, we'll set up some bottom cutoff of 0.05, then we will decrease. So if the character still has power, decrease the character's power. So then my character's power level will be, we're actually going to use that another function from the fmath library, finterp2. So that's just interpolating between the current power level and so if you notice, you should have some auto completion here. So finterp2 takes in the current, the target, the delta time, and the interp speed. So the current is our current power level. We want to interpolate between that and 0. We need to feed in delta seconds, which we already have because we're in the tick function, and our decay rate that we set up just a little bit ago. So basically, as long as the character still has power, we will decrease the character's power and interpolate between the current power level and 0. So that handles what happens if the character still has power. But what happens when we get below 0.05? So game modes are really good places to handle things like game over or win states, and I'm going to start with a game over state. So let's start back in the game mode header, and we're going to make an enum to store whether or not the game is playing or if the game is over. We will call this, or we're just going to call this the play state. And we actually put this way up at the top of the header above even the class declaration. So we've got the play state, which is an enum to store the current state of gameplay. And we've set up a playing state, a game over state, and an unknown state, just in case we have something we want to handle that doesn't fall under either playing or game over. And now that we've set up that enum, we need to create an instance of it. Now, I'm going to make this private. And that is because I don't want any class other than the game mode to be able to set my play state, because the game mode is the only one that's going to have the functions to correctly handle what happens when the state changes or what happens at any given state. So we're going to make that private and make an instance called current state. It's basically store the current play state here in this variable. Now we need 3 functions to deal with the game state. The functions will be used to get the current state, to set the current state, and to handle any changes that need to happen when we go from one state to another. So getting the current state is pretty straightforward, but is going to have to deal with the fact that this is a private variable. So let's set up a function declaration like we had before. So it will return our tutorial code play state, and we'll call this get current state. And we're actually going to define the function right here in the header. We're going to use the force inline macro here as an optimization. And basically all that this function does is return the current state. And you might wonder why we even actually need a function to do this. So the function is not private. The function can be called by other classes. So my character could say, hey, what's my current state? And work with it that way. But it can't directly access the current state. So the character can't switch us from playing to game over, but it can return the current state. So that's just why we've done it this way. We're also going to set up our set current state. So set current state, and that will take as an input our play state. So set our current state to what I'm supplying as my argument. And we'll switch to our source code our source file to define this function. And all that it will really do, set current state, play state, is it will set our current state equal to new state, and it will handle the new state. So like I said, we're going to have a state handler that will say, hey, if you're switching from playing to game over, certain things are going to happen that we need to let other classes know about. So again, having this be a function that changes the current state variable, which is private, means that other classes can call set current state, but the game mode will do all the handling, so there won't be any exceptions or things like that. We are going to make the handle current state function private, so the game mode can work with it. Other classes will be able to change the play state, or like I said, get the play state, but only the game mode can set the behavior of each state. So this is just an example of good practices as far as keeping the variables private within the class so the class can work with them, but creating sort of helper functions that allow other classes to interact with those variables in a safe way. So like I said, we're going to make our handle new state function private. And that takes as input our tutorial code play state enum. And let's go ahead and set up the handle state function back in our source file. So yes, it's, right now IntelliSense is complaining because the function doesn't exist. But so void a tutorial code game mode handle new state. Yep. Keep wanting to put spaces in there. So this is going to be a switch statement. Basically, it's going to take in the new state and in the case where basically, let's go ahead and set up our cases just with break statements, and we'll fill in the actual behavior later. So we've got the case where we're playing, and we'll just go ahead and break out of that. And we'll have the case where we are the game is over, and we'll go ahead and break out of that. And finally, we've got the case where it's unknown, and we'll sort of line that up with our default case. So unknown, and that'll be the same as default, and we'll just do nothing here. Like, we're never going to add extra behavior here. So if we don't know the play state, just do nothing and break. So the last thing we'll do in this video is answer that question of what happens if our character's power level does get too low. So that was back in our tick function. Just space this out a little bit real quick. Okay, so back in our tick function, we have if my character's power level is greater than 0.05, decrease the character's power. Then else set current state e tutorial code play state e game over. So that answers the what happens if the character's power level is too low. We set the current state to game over, which then calls the handle new state. So in the next video, we'll work on changing our game mode character and spawn volume behavior based on our play state. Go ahead and save and then check back in the next video. Thanks.